start a numerical of Sarada fall. Okay, before this video we already discussed about the basic concept of related to Sarada fall and what are the different parameters that we should know during the solving this numerical. Okay, so I first recommend please visit our first video. Okay, in previous video we already discussed about different parameter, that is what is h, d, hl and x. Okay, so this is all parameter we already discussed in previous video. So you have to see first this video, and I will give on the link in description box. Okay, so let's see the question. So you can see here we have a question. This question is asked in Pokhara University 2013 fall, and this is repeatedly asked. You can see here this is also asked in 13, 14, 15, 18, 16 and 18. Okay, so this question is repeatedly asked. Design a 1.5 meter Sarada fall type for a canal carrying a discharge of 12 cubic. So here you can see the given over here the discharge is 12 cubic. Simply, so you can say discharge equal to 12 meter cube per second. Okay, you can like that, q equal to 12 meter cube per second. Okay, and as I discussed in first video, the length of crest is taken, that is the value of L equal to downstream bed width of the cable, width of the canal, and this value is given. Bed level of stream equal to 103 meter, downstream 101.5, side slope 1:1, full supply level of stream 104.5, bed width of stream and downstream 10 meter, and swell equal to good lump, and blast coefficient equal to 6. So this is all parameter given over here. Okay, and as we discussed, length of crest is always equal to a downstream bed width of a canal, and downstream bed width of a canal is given over here. You can see the bed width of upstream and downstream equal to 10 meter. That's why the length of crest also 10 meter. Video of those link in description box. You can simply visit from there. Okay, and I have already discussed about the basic knowledge about the different parameter for the designing of Sarada fall in previous video. Okay, so you have to first see the previous video. After that you can easily understand the design steps of Sarada fall. So in first step we have to design, we have to determine the length of crest, and the length of crest is simply taken downstream bed width of a canal. Okay, and in step number 2, okay, we have to determine the shape of crest. Okay, and the shape of crest we can simply we have the criteria over here. Whenever the discharge is less than 14 meter cube per second, then we have to provide rectangular crest, and whenever the discharge is greater or equal to 14, then we have to provide a trapezoidal crest. Okay, so these are the two criteria for the shape of crest. Okay, and whenever we provide rectangular crest, we have top width of crest, that is bt equal to 0.55 root d, and for the trapezoidal bt equal to 0.55 root d plus h, and base width equal to h plus d by 2 for rectangular, and the discharge equal to 1.84 LH to the power 3 by 2 h by bt to the power 1 by 6. And for the trapezoidal crest, the discharge is changes only in this constant. Otherwise, all this value is taken same, and the value of this constant 1.84 we have to use 1.89. Okay, for the trapezoidal crest. So we use this formula, and you can simply determine these all parameters. Then in step number 3, we have to calculate the crest level. Okay, simply the crest level, that is the value of h equal to what, and using this formula q equal to 1.84, this formula and this formula, we have already value of L, bt and bt, these two value, and the discharge is also known, and simply with the help of this formula we can calculate the value of h, that is crest level. Okay, and whenever the value of whenever the crest is rectangular crest, we have to take the value of bt is less than 1. Okay, and you can take the value like 0.8 or 0.9, and whenever the crest type is trapezoidal crest, then we have to take the value of bt, this b2 bt value equal to 1. Okay, and this b2 is called top width of crest, And in next step number 4, this is the design of cotton wall, and you can say the upstream and downstream of cotton wall, and this value is taken for the upstream depth equal to y by 3, and for downstream depth y distance from distance to downstream by 2, and for the upstream we have to divide this upstream distance by 3. Okay, and this value is taken also from the table as we discussed in numerical in previous video also, and we will further describe in during the numerical. Okay, and in next step, this is the fifth step, and this is for the cistern. We have to calculate the length of system, or you can say depth of system as well. Okay, for this we use the length of system, that is the value of LC equal to 5 HL into L. So I already discussed the length of system is taken is this LC. Okay, from here to here, this is the length of cistern. Okay, and you can say this is LC, and this is called a cistern. Why we provide this cistern? We provide this cistern for the prevention of erosion of soil, because whenever the water falls from here, it hit the ground and there may be erosion of soil. That's why we provide some level of water, that is called in X level. Okay, from ground to X level we provide water over here. Okay, why we provide water? For the prevention of erosion of soil. Okay, and then simply we can calculate the length of cistern, that is the value of LC equal to 5 HL into H, and the value of H equal to head over crest up to TEL. As I discussed over here, the value of head, velocity head, that is H equal to from the upstream of full supply level to the upstream of total energy level. Okay, this is the value of head over the crest. Okay, up to TEL. Okay, over the crest is this. Okay, sorry, the value of H is calculated from the top of the crest, from the here to upstream of total energy level. This is the value of H from here to here, capital H. Okay, and HL can be simply calculated. HL is the head difference. Head difference can be calculated with the upstream full supply level minus downstream full supply level. You can see here, this is the head difference, and this is denoted by HL. This is distance from here to here, and this is upstream full supply level, and this is downstream full supply level. Okay, for this we have to divide upstream full supply level, subtract minus downstream full supply level. Then we can easily get the value of HL. Okay, and we can calculate this length of system and depth of system. And in next step, this is sixth step, and in this step we have to calculate the impervious floor, that is thickness of floor. Okay, in this impervious floor we have to determine the length of the impervious floor. Okay, and this can be determined using the Blaise or Khosla theory. And the minimum length of downstream floor equal to 2 times of water depth plus 1.2 into head difference, or simply you can say head difference drop. Okay, and in the you can say in this like that, 2 into water depth is denoted by D plus 1.2 and the head difference, that is value of HL. Okay, so simply using this formula, okay, we can calculate minimum length of downstream floor. Okay, and in next step, in step number 7, we have to calculate uplift and thickness. So for the thickness we use simply T equal to H by G minus 1, and the value of G is taken 2400. Okay, or simply you can say 2.4. As we know, for the plain type of concrete we use the value of G equal to 2.4. So we just take the value of G equal to 2.4 for the plain concrete. Okay, and H we will see in numerical how we calculate the value of H, and after that we have to determine the total length of downstream pitching. In next step, in step number 8, the total length of downstream pitching can be calculated with the help of table. Okay, this value can be calculated with the help of table, and generally we prefer 9 plus 2 HL. Okay, and HL is already we discussed about HL, that is HL is the head difference. Okay, this is the HL. Okay, and we have already calculated this value. So brick pitching equal to, you can also take 18 plus HL. This depends upon the from the table, and generally we prefer 9 plus 2 HL, and the slope is taken 1:10. Okay, and this slope is like this. This slope is taken 1:10. Okay, so this is all about the design steps of the Sarada fall. During Sarada fall, okay, now let's see numerical related to design of Sarada fall, and we will follow these all steps. Okay, so basically we have total 8 steps for the design of Sarada fall. So let's see these all steps, and let's do one numerical. So we have given numerical here. Okay, and we will solve this numerical using these steps of Sarada fall. Okay, so let's start. And in second number, we have to provide shape of crest is rectangular. Okay, why is rectangular? This depends on the discharge. Okay, and whenever the discharge is less than 14, we have to provide a rectangular crest, as we discussed in previous video. And whenever the discharge is equal to or greater than 14, we have to provide trapezoidal crest. Okay, but in this video, in this numerical, we have discharge given 12 cubic. That's why we have to provide shape of crest is rectangular. Okay, and this is also we discussed in the previous video. Okay, in that video we have already studied about the different steps that we should follow during the designing of Sarada fall. So you must see first video related to designing steps or design criteria of the this Sarada fall. Okay, now let's see in third number. In design steps of third number, we have to calculate crest level. Okay, simply for crest level, here rectangular crest is provided. Why this provided? Because we have discharge is 12 meter cube per second, and this is less than 14. Okay, and we use this formula, Q equal to 1.84 LH to the power 3/2 into H by BT to the power 1/6. Why we use this formula? Because we have already provided rectangular channel, rectangular crest. Okay, and you can see here for rectangular crest we use this formula, Q equal to 1.84, and for the trapezoidal crest we use this formula, Q equal to 1.99. Okay, only just constant is different. And third step, we have to calculate the crest level, and the crest level equal to rectangular crest is provided. We already discussed in second step. For the rectangular crest, we have to use value of Q equal to 1.84, this formula. Okay, and the value of BT is taken less than 1 for the rectangular crest and equal to 1 for the trapezoidal crest. For this we have rectangular crest, so just take the width of the crest, that is value of BT equal to 0.8. so we just keep the value of BT equal to 0. In this formula, so 0.8, and on the value of discharge is taken 12 given in question. Okay, and everything is known, that is the value of L is we have already calculated, L equal to 10, and everything is known except the value of H. So the value of H after calculating 0.76 meter became. Okay, now we can calculate approach velocity equal to Q by A, and the value of Q is 12, and it can be calculated by the L plus D times of D. Okay, so L is 10, D is 1.5, and we have to multiply with the D, that is 1.5, after calculating the approach velocity BA equal to 0.69, and depth of water we have already given in question, and that is the value of Y equal to 1.5 meter. So we can calculate velocity head. Okay, and velocity head simply you can say the value of BS equal to BA squared by 2G. Okay, and BA equal to 0.69 squared by 2 into G equal to 9.81. So the velocity head becomes 0.025 meter. Okay, in the figure we have this is the velocity head, and this velocity head from upstream of total energy level to the down upstream of full supply level, and the velocity head becomes 0.025 meter. And now we have to calculate the upstream total energy level, that is this level. Okay, upstream total energy level, and you can we can calculate this level by the upstream full supply level to the velocity head. Upstream of full supply level, you can see here when we add in this upstream of full supply level of the velocity head, we reach here. Okay, that is the upstream of total energy level. So for upstream of total energy level, upstream of full supply level, that is 104.5 given in question, and velocity head that we have calculated over here 0.025. So we just add these two value. After adding, we get upstream of total energy level is 104.5. so you can like this that 104.5. okay, now we have to calculate RL of crest. Okay, the RL of crest is this. For this we can simply after subtracting the value of H from here, the total energy line, subtracting the value of this, we get the value of this of top crest. Okay, RL of top crest. That's why for the RL of crest we have to subtract the value of H from the upstream total energy line. So we have calculated upstream of total line equal to 104.5 minus the value of H. The value of H is we already calculated, and the value of H is 0.75 or 0.76. You can see here. Then the RL of crest becomes 103.7. You can write simply here 103.7. Okay, now we have to calculate height of crest above the upstream bed. Height of crest above the top upstream of bed, that is we have to calculate the value of this from here to here. Top of crest this, and upstream of bed is this. So we have to calculate this value. Okay, so height of crest above the upstream bed, simply we have to subtract this value from this value. Okay, so we have already calculated 103.7 minus we have to divide the downstream of bed. Okay, then that is downstream of HFL. Okay, and this is given in equation 103. You can see here. Okay, bed level of upstream 1.103 meter. So just we divide, after we get the value 0.77 meter. Okay, and for the value of D, you can see here the value of D. We can calculate the value of D. Okay, so the value of D equal to upstream of bed minus downstream of bed, and we already calculated the RL of crest minus downstream of beds. So the RL of crest equal to 103.77. Okay, we already calculated this value here, and minus downstream of bed. The value of downstream of bed equal to 101.5. Okay, this is already given in question 101.5. You can see here bed level downstream 101.5. So we just take this value. Okay, then the value of D becomes 2.27 meter, and we know the value of BT equal to 0.55 Newton under D. So the BT equal to 0.55. We have to keep this value D equal to 2.27 over here, and simply we can calculate the value of BT equal to 0.825. So adopt the width of crest equal to, simply we take 0.85 meter, and the thickness of base can be calculated with the help of this formula H plus D by 2, and the value of H equal to 10.7 and D is 2.27. Okay, and we can calculate the value of H. You can see here we can calculate the value of H by the dividing 0.025 from this value. Okay, that is 0.755. For this small h you see here, for the value of h we have to minus this value, okay, this velocity head from the this capital H. When we minus the value of velocity head from this capital H, we get the value of h. That's why we minus 0.75 minus 0.025 plus a d, and we have already calculated the value of d equal to 2.27. okay, and we just you can see here the value of d equal to 2.27. we just keep here after calculating thickness of base equal to 1.5 meter. The top shall be capped with 20 cm thick concrete, okay, and cement sand aggregate ratio in 1:2:4. okay, so this you can write like this. This will be better for understanding. okay, and in this figure you can see here we have to provide this height, okay, from here to here. This height is provided 20 cm thick concrete, okay, and the cement sand and aggregate is 1:2:4. so this is basically 20 centimeter height. okay, this is the concrete, and after that we have to calculate design of cotton wall. okay, for design of cotton wall, simply the maximum depth of steam cotton wall is taken y/3 as I told in design steps. okay, so the total value of y is given 1.5 in question. You can see here 1.5 meter Sarada fall. okay, so simply we take this value 1.5/3. so the maximum depth of steam cotton wall becomes 0.5, and you can simply say the 1/3 of the water depth. okay, and water depth is given 1.5 meter. So provide 0.4 meter into 0.8 meter cotton wall on up steam. okay, and cross section of rectangular area. okay, so we use this cotton wall 0.4 into 0.8 meter. Now in design steps of 5th, we have to design for the cistern. okay, and the length and length of system can be calculated, and depth of system can be calculated 1/h into HL to the power 2/3. okay, and HL equal to, simply we can calculate HL equal to you can see here for determining the value of HL we have to minus downstream of HFL from the upstream of FSL. so we have upstream of the depth of water, that is value of x equal to 1.5. after adding this value, okay, this is the depth of water, and this is the you can see here downstream of full supply level. After adding this value, bed level of downstream, this value with this value, simply we get the full supply level of downstream. okay, and this value becomes 103. now we have to calculate the value of x. X can be calculated by the 1/4 times of h into HL. so the value of h become 0.73, 0.76, and the value of HL, that we calculated 1.5. okay, so we just keep this value. after that we get the value of x equal to 0.27 and nearly equal to 0.3 meter, and the value of h you can see here, the value of h equal to 0.76. so we just keep this value in this equation. so we get the value of depth of system, that is x equal to 0.3 meter depth. okay, so in this figure you can see also we have to provide depth of system equal to 0.3 meter. now length of system can be calculated with the help of this formula 5 into h. the value of h equal to 0.76 and the value of HL equal to 1.5, as I already told you. okay, the value of HL equal to 1.5 and h equal to 0.76. the value of length of system, that is LC equal to 5.34, nearly equal to 5.4 we have taken. okay, so in this figure you can, that is LC value we have calculated, and this value length of system equal to 5.5 meter. okay, so we just write here 5.5 meter. okay, and depth we also calculated, the depth of system equal to 0.3 meter. okay, so we simply so this So provide 5.5 meter long cistern at RL 101.2 meter. Now in step number 6, that is the calculation of impervious floor length. Okay, for this first we have to calculate the maximum static head, and the maximum static head can be calculated by this. Okay, downstream of bed level. Okay, so this is our downstream of bed level, and when we subtract from top of the crest minus this value, then we get this value. Okay, so we just taken crest level is 103.7, you can see here, and minus downstream of bed level. Okay, and downstream of bed level is 101.5. this is already given in question. Then we get the maximum static head equal to 2.27 meter. Okay, and now we have to calculate the total length of floor, total floor length. Okay, you can see in this figure the total floor length, you can see here. This is the top stream of the curtain wall. Okay, and you can see upstream of curtain wall, and this is the downstream of curtain wall. Okay, now we have to calculate the total length from upstream of curtain wall to the downstream of curtain wall. So you can calculate this value by multiplying C into D. C we have here C value of C equal to 6 and D equal to 2.27. Okay, so this value becomes 13.62, and simply we take 13.7 meter. So the length, total length required, we have calculated 13.7. This is the total length from the upstream of curtain wall to the downstream of curtain wall, 13.7 meter. Okay, as you can see in this figure too. And after calculating the total length, this total length we have to calculate the downstream length. Okay, and downstream length from here. Okay, this is the our toe of cistern wall. For floor length in downstream side, from here to downstream of curtain wall, this value is taken from this side to total here. Okay, and this value we have to calculate, and we already discussed in design criteria. The minimum downstream floor length can be calculated using this formula. This formula is equal to 2 times of water depth plus 1.2, that is constant, plus HL. Okay, and water depth is given 1.5 plus 1.25 plus HL. The value of HL we have already calculated, that is 1.5. Okay, and after calculating we get the minimum downstream floor length equal to 7 meter. Okay, so this value from here to this curtain wall, downstream curtain wall, the value becomes 7 meter. Okay, so this value becomes 7 meter in downstream. Okay, and after knowing this value downstream length 7 meter, then we can simply calculate in the length of upstream. Okay, we have calculated total length is 13.7, but in downstream 7 meter. So we can calculate for the upstream. We can calculate simply upstream this total value 13.7 minus this downstream 7. Then we get this value 6.7 meter. Okay, then the upstream of the length of upstream becomes 6.7 meter. So we just calculated this value, and hence provide 7 meter in downstream floor, 7 meter in downstream floor, and 6.7 meter in upstream floor, 6.7 meter in upstream floor of the crest. Okay, so you can see like that. Now we have to calculate the floor thickness, and for the floor thickness we can simply use the value formula h by g minus 1. Okay, so now we have to find the value of h. Okay, so for this h you have to see in this triangle. Okay, this is our crest, and in this triangle you can see here in this triangle. Okay, this is our triangle. You can see here this like a triangle. Okay, in this triangle we have to we already calculated the RL of this downstream curtain wall is 101.5 meter, and the RL of curtain wall, that is the upstream, you can see here 103.77. Okay, and this value is taken equal to the top of the crest. Okay, and we already calculated the RL of top of the crest is 103.77. 3.77. Okay, that's why this value is also taken equal to the top of the crest. So this value is also becomes 103.7. Okay, and now we have to see in this triangle. Okay, and when we see in this triangle, we have already known the RL of at this point, that is called cotton wall in downstream 101.5. so you can say simply, if we take this as a x equal to 0, okay, then x equal to 0, then the RL of 101.5, and when we take x equal to 13.7, that is from here to here, this distance is 13.7, then the RL becomes in this triangle 103.7. okay, and now we have to calculate the RL at this point. Okay, and this value becomes from here to here, this is 7 meter, then x equal to 7 meter, then we have to calculate the RL of this. Okay, and for this we can calculate RL at a distance of x equal to 7 meter by the interpolation. Okay, and as we know, interpolation is simply we have to divide minus 3.7 minus 101.5, this minus this by this minus this. Okay, 13.7 you can write here or also here, and then we have to by the interpolation 101.5 minus r. Okay, you can simply like this unknown value r, so we have to 101, this value minus this value equal to this value 0 minus 7, so we just keep this value. Okay, and you can by interpolation we get the value 102.65 after the interpolation. Okay, so the value of this RL at a distance of 7 meter, from here at distance of 7 meter we get the value of RL equal to what, 102.6, so we just get this value 102.659. okay, in this triangle, as we take on this all value in this triangle, that's why the value of this becomes at a distance of x equal to 7 meter, RL equal to 102.65 meter. Okay, and now in this figure we can calculate, we have already known this value and also known this value. Okay, this is equal to RL equal to 101.5 for this point. Okay, and simply we can calculate this value by the minus this value from this. Okay, then we get this value. For this we simply minus from 102.6 minus 101.5, then we get the value of this. So we have to minus this value 102.6 minus 101.5, then we get the value of 1.159 meter. Okay, now we have to calculate the toe of crest, that is value of h. We have to calculate this total value. Okay, this is equal to toe of the crest. Okay, and for this value we can simply add this 0.3 into this 0.3 to this value. So now we have calculated from here to here, this is 1.159. now we have to add this distance from here to here, that is 0.3. Then we get the total height equal to 1.459. now we can calculate the thickness required equal to h by g minus 1, h equal to 1.459, and this h is taken from the 7 meter. Okay, from the cotton wall, that is downstream, and this value is taken 1.45 by g minus 1. For the plain concrete we already known the value of g is always taken 2.4 minus 1, then the value of thickness required becomes 1.042 meter. Okay, so provide 0.842 meter thick concrete overlain with 0.2 meter brick masonry. When we overlain with 0.2 meter brick masonry, then we have to divide minus this value from thickness. Okay, so 1.042 minus 0.2, then we get the value of 0.842. so this is the thickness of concrete and this is the brick pitching. Okay, in this way we can calculate it. So the thickness becomes 1.042 meter. Okay, so you can see here this total thickness from here to here becomes 1.042 meter, but we have to provide 0.2 meter brick pitching. Okay, so let's see, this is the brick pitching. Okay, this is brick pitching, which is 0.2 meter. You can say this is 20 cm. Okay, so we have to provide 20 cm brick pitching. Then the remaining portion, that is this portion, 0.8 meter. You can say 0.8 meter. We have to divide this brick pitching from this total thickness. So 1.042 minus 0.2. Then we get this 0.8 meter thickness concrete. Okay, so we have to provide this 0.8 meter thickness of concrete. This is the concrete and this is brick pitching. Okay, so we have to provide 0.8 meter thickness of concrete. So this value becomes 0.8 meter thickness of concrete. Okay, so we calculated here. Okay, now we have to calculate from 3 meter distance from toe of this. So from this 3 meter distance we have to calculate this value. What is the thickness of concrete at that point? Okay, so you can calculate this as usual. Now we have calculated in this video. Okay, so I can also explain this too. So for this point we have, you can see here in this figure, from this point we have distance 3 meter. Okay, so 3 meter, and after this 3 meter this distance becomes 7 minus 3 equal to 4 meter. So this is 4 meter and this is 3 meter. Okay, now we have to find this thickness at a distance of 3 meter from this toe of the this point. So our figure becomes like that. In this figure you can see this is our distance from here is 3 meter and this is becomes 4 meter. Okay, and the value of this is already 101.5 and this value 102.6. So now we have to find the value of RL at this point. Okay, 3 meter from here and you can say 4 meter from this side. Okay, as we done in this by the interpolation, you can simply determine this value. Okay, and at distance 0 at distance 0 the RL is 101.5. At distance 7 meter the RL is total 7 meter. Here the distance RL is 102.6. At 4 meter from this side we are taking from this side. Okay, that's why x equal to 4 meter, the value equal to what? We have to calculate this RL. By the interpolation we get the RL of this value equal to 102.6, and you can by interpolation simply 102.6 minus 105.5 by 101.5 minus this value R. Okay, equal to this value 7 minus 0 by this value 0 minus 4. Okay, after calculating we get RL equal to 102.6 at a distance of 3 meter from this side. Okay, and you can say 4 meter from this side. So the value of this becomes we can simply calculate the h. Okay, and h can be calculated in this by 102.16 from this we have to minus this value. Okay, that is 102.16 minus 101.5 this value. After minus this value we get this depth. Okay, this height. Okay, and the height becomes 0.662, and we can calculate thickness equal to this height by g minus 1. Okay, height by g minus 1, and the value of g is taken 2.4 minus 1, then the thickness becomes 0.7 meter. Okay, now we have thickness is total thickness 0.7 meter. So we have to provide a 0.2 meter brick layer. As I said here, we have to provide this 0.2 meter as a brick layer. Okay, then the remaining portion, this we have to for the remaining portion 0.7, that is total thickness 0.7 minus 2 meter. This is the brick pitch. So after minus this value we get value of concrete is 0.5 meter. So we have to provide 0.5 meter depth of concrete. Okay, and now we can similarly we can find this value at distance from here. We have to provide 0.25 meter concrete, and I have done in this figure. Okay, for this we have to take total distance. You can see here this is from here, this is 3 meter from here and 2 meter. Total distance is 5 meter. Okay, so we taken this 5 meter, and the remaining from the 7 meter remaining distance is 2 meter. Now we have to calculate the RL at that point. Okay, simply as we done in this by the interpolation, 0 the RL at distance 0 1 0 1.5 at a distance 7 meter, the RL equal to 102.6, and the RL at 2 meter. What we can calculate by the interpolation, RL equal to 101.8 meter, and the height can be calculated simply minus this value 101.8 minus 101.5, then we get value of h equal to 0.33, and we can calculate thickness by the using h by g minus 1, and the value of h equal to 0.33 by g minus 1. G is taken 2.4 minus 1, then we get the value 0.45 meter. Okay, and total value over here is 0.45 meter, but we have to provide 0.2 meter as a brick. So this is 0.2 is a brick pitching, then we have to divide this value 0.45 minus 0.2, then we get 0.25 as a concrete. So we have to provide 0.25 as a concrete thickness. Okay, in this way we can calculate concrete thickness at this level and this level and this level. Okay, and at last now we have to calculate total length of downstream pitching equal to 9 plus 2 times of HL. Okay, this is from the table. We have table provided, and 9 plus you can simply use this formula. Okay, this is general formula. 9 plus 2 times of HL. HL becomes 12 meter. Okay, design of Sarada fall. Okay, in this way you can design Sarada fall, and you can show this all design next video.